Section 4.2, page 3. Example 4. If f of 2 equals 11 and the derivative of that same f function is greater than or equal to 1, only for values between 2 to 6, how small can the output at 6 possibly be? Okay, a lot of information going on here, right? So we can see this input value of 2 has an output value of 11. And notice that we're only talking about values between 2 to 6. So that 2 input is our lowest point in the interval, and 6 is the largest point in the interval. So we're going to use the mean value theorem that says so long as our function is continuous on a closed interval from 2 to 6 and differentiable on an open interval from 2 to 6, the derivative of some point in that interval is equal to the slope of the endpoints of that interval. Okay, so all we've done is stated the mean value theorem formula. Now, we're talking about the derivative of the function, and we know it's greater than or equal to 1 for this entire range. And since we're trying to find the smallest, then let's take the smallest it can be, which is 1. So the derivative is a bare minimum a 1. We have our a and b values to plug in. That looks like a c, but it was supposed to be an a. And so we can subtract 6 and 2 to get a 4 ourselves. We don't know f of 6. We're trying to figure out how small it can be. But f of 2, we do know that. It was given initially in the equation or the question as 11. So if we go ahead and try to solve for f of 6, we'll begin by multiplying both sides by 4. That allows us to cancel the 4 on the left and multiply a 4 on the left. I just said my left and right incorrectly. We're going to add the 11 to the other side. 4 plus 11 is 15. So therefore, the smallest 2 the smallest that the derivative can be is 1, and therefore for this situation to give us the smallest 6 output is going to be 15. I think I said that horribly, but hopefully you followed that. Example 5. Suppose there is a derivative that we know is between 4 and 5 for all values of x in some range. What are the minimum and maximum values the outputs of f of 5 minus f of a can be? So what ends up happening is we have a being our smaller input and b being our larger input. Using Rolle's theorem, we said if our function is continuous and differentiable, closed and open intervals, then the derivative is equal to the slope of the secant line connecting the endpoints. So that's all I've written here, where we've gone ahead and plugged the values in for A and plugged the values in for B. Might be a little deceiving that 5 shows up twice, but they're not necessarily directly related for our purposes. Okay, I need to solve this equation. So I can subtract 5 and 1 to get a 4, but since I'm trying to solve for f of 5 minus f of 1, I'm going to go ahead and multiply all 3 parts of our equation by 4, which eliminates it in the denominator. And what I'm left with is that the difference between f of 5 and f of 1 needs to be somewhere between 16 to 20. So the minimum value is 16 and the maximum value is 20. Last example. Does there exist a function such that the input of 0 produces an output of -1, the input of 2 produces an output of 9, and the derivative is always less than 5? So again, taking the mean value theorem, assuming that our function is continuous on a closed interval of a to b and differentiable on that same open interval, we can plug in what information we have. So we have an f of b and an f of a, which means we know what b and a are, so we can subtract those to get a 2. We are also respectively given those outputs, so we can plug them in. and doing math, we get 6.5. Now remember, this is equal to the derivative. The derivative is 6.5, but the question asks, is there a function such that the derivative is always less than 5? Not in our case, because we got a derivative bigger than 5. Therefore, there is not a function that satisfies these two conditions.